really two-part, and we already know this. The first part has to do with the integrals, and it tells us that if you have a continuous function, a and b are representing the endpoints. Okay, x is the variable. So if we want to integrate this function from a constant up to a variable, then that variable could be changing, right? We're starting at a fixed spot, but it's like saying the area under the curve up to whatever x is, and x would be a moving point. And so it's essentially finding a formula for that area. T here is just representing, normally you would see it as an x, but we don't want multiple x's in a problem, so that's why we're calling it T. So we can see if it were positive, we know area, this is area between the x-axis and the curve. If it were below the x-axis, your area would turn out to be negatives. Okay, so this is essentially telling us the area up to a certain point. If I want to calculate the integral from 0 to x of this function, here's the graph of f of t. Let's calculate each of these. So when I say g of 0, that means the area starting at 0 and ending at 0. If you start and end at the same point, what's your area?
0.
0. So we haven't gotten anywhere yet. When I say g of 1, g is the integral, or the area, between 0 and 1. So if I am trying to approximate each of these boxes as an area of 1, right, length times width.
So 2 or 1.
I think it's, yeah, if I took this little piece and flipped it down, it would approximately give me a whole box. Can you agree?
Yeah.
Okay, so when I say g of 2, we already have 1.
3.
This would add in 2 more boxes, so that'd be 3. If I say g of 3, so we're already at 3, how much more would I be adding?
4.
Yeah, it's more than,
Oh, I did see the other half.
yeah, it's more than a whole box, so I want to say that's another 1.3 boxes, plus the 3 you already have, so 4.3. What happens though when I do g of 4?
We lose the 1.3, so it's 3.
Okay, these are below, so those are negative. So it's like subtracting that 1.3, so it takes us back to 3. When we say g of 5,
That subtracts another 1.3, so it's 1.7.
you guys agree with that? So this is just really, the purpose of that is to give us a visual of what this is telling us. It's an area up to a point. Area is between the curve and the x-axis, above the axis positive, below negative. And so if I integrate it from 0 to 7, the overall area, 1.7, has the positive minus the negative included in it. And then I asked you to sketch a graph of g. So I think I gave you a blank grid. So we're just plotting those points. So this is going to be our g of x graph. We had 0, 0, 1, 1, 2, 3, 3, 4.3, 4, 3, and 5, 1.7. So our graph is something like this. Is it perfect? Absolutely not. But we have a rough sketch.
Now we do the area under this.
Ooh. I mean, we could just have this never-ending cycle. Alright. So the first part of the fundamental theorem of calculus is just how integrals work. If you have the integral from a to x of f of t dt, then the derivative of this, a derivative cancels an integral, right? Derivatives and integrals are opposites. But if you integrated this, your t would get switched into x's. And so it tells us the derivative of our integral is just f of x. If you have a variable in your limit, that would replace the variable in the function. And so what we're going to do is look at this, and I'm going to show you kind of why this works. So if I ask you to do this 2 different ways, First of all, we know how to work this out, so I'm going to work it out first. What is the antiderivative of t squared?
1/3 t cubed.
What is the antiderivative of 2t?
T squared,
What is the antiderivative of 1?
T, or,
Yeah.
And we're doing that from 3 to x. We get 1/3 x cubed minus x squared plus x minus.
Wait, how did you get a minus x squared?
I put in a 3. 1/3 times 2 cubed plus 3 squared plus 2. 3 cubed is 27 times a third is 9 plus 9 plus 3. Okay, here is the integral. But what did I ask you to do to that?
solve.
Find the derivative.
Okay, so that was the integral. So the derivative, what is the derivative of 1/3 x cubed?
X squared.
What's the derivative of x squared?
And
2x, right? So 2 comes down.
oh yeah.
What's the derivative of x?
1.
What's the derivative of negative 21? Okay, so if I did it by working out, I get a derivative of x squared plus 2x plus 1. So the fundamental theorem of calculus tells me derivatives and integrals cancel each other. So if you want the derivative of this integral, you don't have to bother working it out as long as it fits a couple requirements. It has to be going from 3 up to a variable, or from a constant to a variable. If both of them were constants, your answer would be a number, and the derivative of a number is 0. But if one of them is a variable, we can do that fundamental theorem, and it tells us all you have to do is drop your integral and change your t's to x's. And so you get x squared plus 2x plus 1. So a derivative and an integral cancel each other. Right? And it would just change my variable to match that one. Is that okay?
Yeah.
All right. So, if I said find the derivative of this, you could choose to work the whole thing out, or what is the derivative going to be?
Radical 1 plus x squared.
Because it went from a constant to a variable, so we just plug it in. What if I did this though? That's different, so let's work it out and see. Why is this one not the same?
Because x is
It's
the
x to
4th.
the
It's x to the 4th. Okay. So if I want to work this out, first we have to do the antiderivative. What is the antiderivative of 2t?
T
T
squared.
squared,
Minus 3t.
I'm going to evaluate from 1 to x to the 4th. So if I do that, I have x to the 4th squared. That's 3x to the 4th. Minus, if I put in a 1, let's break this 3 times. So we get x to the 8th plus 3x to the 4th minus 1 minus 3 is negative 2, so minus negative 2 is plus 2. I changed mine. I'm apparently having sign issues today. I need to watch those. My minus became a plus right in the middle of my problem.
two.
Hmm?
I said better watch the cosines too.
I thought that, but I didn't say it because it was too stupid to say.
Okay, but now what am I asking you to do to this?
The derivative.
Derivative. So the derivative. What's the derivative of x to the 8th?
8x to the 7th.
Minus.
12x cubed.
Okay. Can we figure out how that is related to the 2t minus 3?
4 times 2.
Okay, 4 times 2 is 8, 4 times 3. So what if I factored out? What's my greatest common factor here? And that would give me,
You do the derivative of the x common and then multiply it in multiple places.
so you replace your t with x to the 4th, but then you multiply, what's 4t cubed? The derivative of x to the 4th. It's kind of like a chain rule. So if you don't want to work it out the long way, if I ask you to do the derivative of this, if your variable isn't just a plain x, you still sub it in for your t, and then you multiply by the derivative of that. So if I ask you to do the derivative of this interval, if we don't want to work it out, we know the derivative of the integral, those would cancel. My t would become x to the 4th, and then what would I have to multiply this all by? This does require our functions to be continuous. I said that, but I'm kind of glossing over it because we have to have continuous functions in order to be able to do our antiderivatives, right? Otherwise, we have to do piecewise.
Hasn't that been like the last 7 years?
Yeah.
Was
I
there not to be
mean,
continuous?
everything's been continuous for a long time, so we are still assuming that. Okay, second part of the fundamental theorem of calculus is what we were already doing. That if you're evaluating an integral, you do the antiderivative of the top minus the bottom. We just didn't say that was the fundamental theorem of calculus, but we've been doing it already. So that's the fundamental theorem, a two-part thing. Part 1 is the new part 2 is what we've already done. So we're still practicing integrals. They're not going to go away for a while. So we're going to continue having them. If I ask you to evaluate this integral, what is the antiderivative of e to the x? I'm going to evaluate from 1 to 3. So if I plug in, I get third minus e to the first, or just e. Alright. What if I asked you to find the area under parabola y equals x squared from 0 to 1? So,
Summation of the 1 is b.
okay, you can do it with your whole summation. Yeah, don't we know at this point that an integral is the area under a curve? So we could say this is just the integral from where to where? Of x squared dx.
That's the thing I meant to say, but I said summation, but I meant
Yeah,
that.
a summation, if you do, the limit is goes to infinity of the sum from 1 to n, that is an integral. So antiderivative of x squared.
1/3.
So you could take out your 1/3 if you wanted. 1 cubed minus 0 cubed, we just get 1/3.
So that'd be x to the negative 1.
What has a derivative of x to
Oh,
the negative
natural
1?
log.
And if you try just adding 1, that takes it to x to the 0, so we know that's wrong. That's what makes us think about what else it would be. So this is just the natural log of 6 minus the natural log of 3. Hey, bonus question. Do you remember how to condense those logs?
Is it
You
divide?
can pull it 6/3,
Yeah.
which comes into 2.
Very good.
Oh.
Yep.
It's been a minute.
Do you remember log bases?
And then the exponent, and it's actually e to the whatever.
Yep, if the logs are added, you would multiply.
E to the blank.
Oh, you are not gone
equals-
for that month. Let me
No.
tell you.
E to
E
the
to the
x
blank
equals 2,
yeah.
and then you solve for.
Yeah, and it's gonna be
I
a
didn't
really
know.
funky number, because E's a really funky number.
logs in algebra.
Yeah, you start them at the end of algebra too, and then we did them in pre-calc.
The mowing stuff.
Okay, let's do a fun one.
The
Fun
fun
one. Oh yeah, the piecewise.
Well, so we have to do it piecewise, right? We have to break it up. Okay. So, first, we always have to decide where to break it up by figuring out what makes the inside 0.
Whoa. I
Oh.
look back up and there's a lot of math going on.
Sorry, I was writing, not talking. So, set the inside equal to 0. You can factor out the x, and then do difference of squares.
So 1 or -1
And 0.
and 0. So oh.
Okay.
Oh.
So we are going to have to go from -1 to 0, and from 0 to 1, and from 1 to 2,
What, two?
because that's the end of our.
Yeah.
So
Yeah.
basically, we know that this graph, whatever it looks like, hits the x-axis at -1, 0, 1. When I say absolute value, I mean telling you that I don't want you to subtract off the part underneath. So that's why we're breaking it up. We're going to go from -1 to 0, from 0 to 1, and then from 1 to 2.
Is it good at that? No. Is it like a W, you think? Or is it like a...
I'm pretty sure this would be our graph.
Absolute value 1.2.
Well, yeah, this is the graph of the x cubed minus x, not the absolute value of it. I was just kind of talking through.
yeah.
Well, in behavior, it looks like a chair. None of your zeros have a multiplicity, so it doesn't bounce. It just goes through.
Yeah, we all learned this, right,
Uh-huh.
right guys?
You did.
Yeah, we did, because the bounces mean boom.
Yeah, if something were squared, it would bounce, so it would have like hit it and came back up. Yeah. Okay, let's just check. If I put in a number between -1 and 0, so like -1/2, I need to know if this is positive or negative. Okay, so -1/2 cubed is -1/8 minus -1/2. Is that positive or negative? Positive. So does the absolute value change though? No. So between -1 and 0, I'm just integrating my normal function. If I put in something between 0 and 1, so like a positive 1/2. 1/2 cubed is 1/8 minus 1/2. Is that positive or negative?
Negative.
So the absolute value does the opposite, so it'd be -x cubed plus x.
And then we're back to the original.
If you go between 1 and 2, so like 1.5 or 3/2, if you cube that, you get 27/8 minus 3/2. Is that positive or negative?
I couldn't. Oh. Yeah, it's way positive, because 27. Yeah.
This would be like 12/8, so 27 minus 12 is positive. Okay, so we just have to integrate all three of these. Okay. Antiderivative of x cubed
1/4 x squared.
minus antiderivative of x.
1/2 x squared.
Okay, next one, the signs are just going to be flipped, so -1/4 x to the 4 plus 1/2 x squared and 0 to 1, and this one back to the original. Alright, so just a lot of calculation. If we put in 0, we get a 0. Put in -1, -1 to the 4th is positive, so you get 1/4 minus 1/2. This one, if I put in a 1, get -1/4 plus 1/2. Minus, put in 0, we get 0. Put in a 2. 2 to the 4th is 16 times 1/4 is 4. 2 squared is 4 times a half is 2. And then 1. What am I asking you to do on this one?
Derivative,
Derivative. What happens if you have a derivative and an integral?
they cancel.
They cancel. What I'm going to do is replace my t's with
X squared.
squared. So we have x squared cubed sine of x squared. But since it wasn't just a plain x, what else do I have to do?
Times 2x.
3x to the 6th sine of x squared times 2x or 2x to the 7th.
Sounds like doing the antiderivative, just like.
Yeah, it's asking you to do both. Do the antiderivative, then do the derivative. So they cancel each other.
Oh.
Alright. Do I stop or do I keep going? There's actually not much left. I'm going to stop, but tomorrow I'm going to teach and I may start the next section before the end of class tomorrow. Okay. So, we'll see how it goes. This is your assignment. Make sure you're watching your odds and every other odd